Hey everyone, welcome back to another session in IBDP MAI HLSL course, and today we are going to cover SL 1.7. In this, we will deal with the problems like amortization and annuities using the technology. We have already seen how to solve these problems using the formulas, okay? As it is also mentioned in your guide that knowledge of the annuity formula will enhance the understanding, but it will not be asked in examination directly, okay? So we will use our calculator. There is a built-in financial package, TBM solver or finance solver in your calculator that you can use. Okay, so let me tell you few things that you need to know before directly jumping into the finance solver. As you are already aware of the compound interest and the simple interest, in the simple interest, you get the same amount after every year. But in compounding year, you get the interest on the previous year's amount, which increases, right? Or if its value is depreciating, so it gets depreciated by some other amount every year. Okay. So for the simple interest part, let's say C represents the capital that you paid or you borrowed. R is the rate of interest. N is the total duration of the investment or the loan. Okay. Now, I is the amount when you add it to the investment or the loan. So as we know, the final amount is given by the capital that you have C plus the interest amount. So I'll write it simple interest. Okay, which is given by the capital original amount plus simple interest is given by capital times rate of interest multiplied by time divided by 100. Okay, you all have all these information, so you can always find the amount, or if amount is given, then you can again use the same value for finding any other unknown, like if rate of interest is not given to you. So yes, you can solve using your either numerical solver or by hand to get the value of r for the given values. Now if you have compound interest based problems, let's say FV represents the future value. So we know that future value is given by the present value times 1 plus R, where R is the rate of interest, over K times 100 I will write. If it is compounded K times in a year, so K times 100 raised to the N, your number of years, multiplied by K. If compounding is done K times in an year. Okay. So this is the formula that we can use by hand or by technology also. Okay. So always remember, using this TVM solver, if we are paying something, okay, if money is coming out from us, so that will come with a negative sign. And if we are getting some amount, that will be coming with a positive sign. Okay. So always remember this thing. Sign convention is very important in this. Okay. So let's start with a question and how to solve the using the TVM solver. Here is the question. It says Nicole invests 16,500 in a savings scheme paying compound interest at a rate of 2.1 per annum compounded monthly. Monthly. Okay. And calculate how long will it take for Nicole's money to get double in the value. So without even using the calculator also we can get the answer. But okay, let's see how we can use our TVM solver. So go to menu. Okay, in your calculator, go to menu, then go to TVM solver or finance solver in your calculator. Okay, that gives us, shows a picture like this. I'll show you like this one. Okay, now go to finance and finance solver. So now let me tell you what represented by n and all. So n represents time period, how many times you are making that payment in any in total, or you are getting this time. Okay, in this question, yes, we are looking for that value of n, right? So here, next thing is I, interest rate. What is that? 2.1. So put 2.1 over here. Present value. What's the present value? It is one time payment only. We paid 16,500. Money came out of us. So present value is negative 16,500. PMT. PMT represents payment that you are making after a fixed interval of time, or every month if you are paying, or if you are paying for a loan. Okay, so that is your PMT. payment. But this time we are not making any other payment. It is only one time payment. So 0 is the value of that. Future value. We want our money to get double. So what is that? 33,000 double of 16,500. It is positive. Why? Because we are going to get this value at the end. Payments per year. How many payments you are making per year? You are just making one payment only. Okay. After that, compounding per year, it is 12. Okay. And now last is payment at, whether you are making that payment in the beginning or at the end. So in this time, we are paying that amount in the beginning. Okay. So now when you enter all these values, leave the n part as it is, then go back to n part and hit enter. Okay. When you put all these values, 2.1 minus 6500, 0, 33,000, one payment per year. It's only one time payment. Compounding is 12 times and we are paying this money only in the beginning this time. Okay. Now go back to n part and hit enter. That shows us this value is 33.05 something. 035. So I'll write 03 something. Okay. So that's the n value. After these many years, the money gets double of itself. So you can say in the 34th year or after 33 years. Okay. Let's move to the next question and see how we can solve for other parameters also. When you are paying for something or you are taking loan or okay, Met takes out a 20 years loan of 176,500 to buy an apartment. The nominal annual interest rate is 3.75 compounded monthly. Mets makes his repayment monthly. So payments made per year is 12 this time. Compounding per year is also right because it is compounded monthly. So compounding per year is also 12 in this case. Now the first part says find the repayment that Mets makes each month. So what we have to do? Here we have to find how much amount we need to pay every month. So that is our payment PMT part. Correct? That will come with a negative sign automatically. After that it says hence find the total interest Mets pays over 20 years of his loan. How can we get this? Once we get the final amount that we have to pay, okay, including the interest and everything, how much amount we are paying for those many times n, and that will be my final amount paid. If I subtract the loan amount from that, I will get the interest paid. Okay, so that is going to be my approach to solve this problem. Now let's get back to our GDC. When I open the finance solver, it shows the following things. Let's put the values. First one, n. So you are doing it for 20 years. So let me put 20 times 12 because you are doing it for every month, right? So 12 times 20 or automatically it will take it as 240. Next is interest rate. What is that? 3.75. So put 3.75. Next is PV, present value. What is the present value this time? Present value of your loan is this 176,500. So that is 176,500. So this time we have this amount. Okay, so we are not paying it. We have this amount. So it is positive. Payment, leave this as it is. No need to touch that. Okay, go to next. Future value, we want to repay the loan, so we want future value to be 0. Payments per year, payments per year is what? This time it is 12 because we are making 12 payments. Compounding per year is also 12 in this. Okay, so put compounding as 12. Now last part is payment at. So you are paying in the beginning or at the end? So obviously you are paying for some loan. So you will not pay directly when you get the money. You will pay after 1 month, or you can say at the end of that month. Okay. So I'll select end part here. Now go back to the payment option again. After entering all these values, if you still have any doubt, you can ask me in the comment box. Go back to the payment and hit enter over here. So when I hit enter, I'm getting minus 1046, 1046.4478. Okay, so that's the amount that we have to pay. Okay, as the monthly payment. TMT we got, that's the answer for the first part. Now copy this value, press Ctrl C, and you can copy this value. Okay, so we are doing it for how many? As you have seen, 240 times. We are paying this amount in 240 payments. Okay, so go back to your calculator now again. So 240 times that value multiplied. Okay, so I'm getting this much amount. The PMT, which is this minus 1046.477 multiplied by 240, gives 251147. 251,447. This much amount is to be paid. Now subtract it from the loan amount. What is that? 176,500. So now apply that. I'm getting answer as 74,647.5. That's the amount. What amount? Interest amount that we paid over this 176,500. This much loan amount makes this much interest amount. Okay, now you can see how easy it is to use this TBM solver to get the answers. Okay, if you have to find any other parameter, just go to leave that blank, go to that part, fill all the values, hit enter, automatically it will give you the answer. No need to apply any formula. Next one. It says Yemo wishes to invest in a saving scheme for her retirement. Her financial advisor points two options for her to choose from. Each are for a period of 25 years. Okay. Now, a deposit of equal amount 350 every month in the option A, and annual interest rate is 4% compounded monthly. That's the one way. Now option B says this time pay 450, right, every month, but nominal interest is 2.1, and now it says it is also compounded monthly. Okay, so find the each investment after 25 years. First we have to calculate that value, and after that hence state which option is good for her. Okay, so in this way, in this question, what we are going to do, everything will depend on the final amount that we are going to get at the end of 25 years. If whichever is giving us the more amount will be beneficial for us. Okay, so now you can pause the video or try this question all by yourself. Okay, if you are done with this, okay, let's see, and you can verify your solution with mine. For the first part, option A, n. What is n? How many payments you are making? You are doing it for 25 year and 12, right, payments in a year. So it is 25 times 12. That gives me 300 for the value of n. In both the cases it will be same. Okay, option A or option B. This is corresponding to option A and this is corresponding to option B. I is the interest rate. What is that? For the option A it is 4. PV, present value. What is the present value? Nothing. It was 0 in the beginning. Okay. Payment, what we are making? Negative 350 for the first option. Future value that we have to calculate. Leave it as it is. Payments per year. 12 payments per year. Compounding per year is again 12 payments made at the beginning, because it's investment. It is not repaying something. Okay. So when you enter all these values, Payment is negative 350. Future value is to be calculated. Payments per year 12. Compounding per year 12. And now let me change it to beginning. Done. Now go back to the future value part and hit enter. So it gives me this much amount, 180,000, sorry, 180,400, 545, sorry. Okay, this much amount. Now if I use the second scheme, what's the interest rate here? It is changed to 2.1. Now change that only to 2.1. And now the amount is also changed to present value is 0. Again, payment is changed to negative 450. So let's make this minus 450. Keeping the future value blank, payments per year 12, compounding per year 12, payment is made at the beginning. Okay, go back to future value and hit enter. This time you will get 177,657. Okay, 0.5 something. So which one you think is good? This one. Why? Because this one is giving us more amount even by paying a small amount. See, 350 per month payment is made. And in this second option, we are paying 450. Still, we are getting a lesser amount. That is only depending on the interest basically. Okay, that's the only reason. Because timing is same, compounding per year, compound payments per year, payment beginning, everything is same, but because of the interest rates, as you can see, even by making the payment of that 350, we are getting more final value. Okay, so in the first part it asked for find the value in each investment, that we got already. B part it says hence state which option EMO should choose. So yes, option A is better, because by making small payment getting more amount. Okay, so now in this session we are done with the questions related to the either mortgage loan or investment plans. Okay, so that's it for this session. Now I'm giving you a question for you to try. You can try this question all by yourself and write down the answer in the comment box. See you in the next part. Thank you for watching this. Keep watching, keep learning.